So I want to kind of step back a bit now. We're going to come back to this scenario in a few slides' time. But I want to step back a little bit to talk about what's going on inside the body and brain when this happens, when we're under stress. And to do that, we have to talk a little bit about why the stress response developed in the first place. Because often we think about stress as only being a negative thing. But actually, as psychologists, when we talk about stress, it's both a positive and a negative thing. Stress isn't inherently bad. It's to do with the amount of stress and how appropriate it is in that situation. But actually, if we didn't have stress, we wouldn't have survived as a species. So basically, when we're under stress, this is all to do with our nervous system. So our nervous system is the network of nerves throughout the body that connect our brain to our organs. And it's split into two systems, the parasympathetic system and the sympathetic system. So the parasympathetic system, you might have heard of it already. Sometimes it's called the rest and digest system. So when we're calm and our body's regulated, our parasympathetic system is activated. The sympathetic system is sometimes called our fight or flight system. So that's what's activated when we're under stress in a stressful situation. And our nervous system controls lots of our bodily systems. So all the things that just happen without our conscious awareness, like our breathing, our heart rate, and our blood pressure, that's all controlled by our parasympathetic and our sympathetic system. So the way it works is like a barometer. So our nervous system scans the environment constantly without us realizing that this is happening. It scans the environment for cues of threat or cues of safety, and it organizes our bodily processes accordingly. So if it detects cues of safety, our parasympathetic system is in control. If it detects cues of threat, then our sympathetic system comes online. Now, we need both of those systems. It's not that one is good and one is bad. We need both of them. But fight or flight is a survival mechanism. So if danger is detected, the sympathetic system takes over and we have this fight or flight response. Now, what that actually means is our sympathetic system sends messages to all these different biological systems in our body to make these things happen. So our heart rate increases and our blood pressure increases. Now, most people know that about stress. What I didn't realise until kind of more recently is the reason why we have that. Why does our heart rate increase when we're stressed? It's not just by chance. It's to give more oxygen to our lungs and our muscles, because that's what we would need in a fight or flight situation. Okay, so we have to remember that when our brains developed and this kind of stress response first evolved, it was back in time when we had to face a lot of predators as early humans. You know, in those days, you'd have had kind of real threats to your life on a kind of daily or weekly basis. Something's trying to eat you, or you're trying to catch an animal so that you can hunt it and eat that. And so what you need in that situation is lots of oxygen to the lungs and muscles to prepare you to fight or hunt or to run away if you're in danger. For the same reason, when we're stressed, our liver converts glycogen to glucose, and that's to give us an energy surge for that fight or flight response as well. We also have cortisol and adrenaline that get released into our system. That gives us an energy surge and also a feeling of strength. So you might have seen on those kind of those like rescue programs where people display like extreme strength and manage to like lift up a car to save a trapped child underneath. That is a stress response. So that's one example of when a stress response can actually be really useful. That cortisol and adrenaline can give us kind of almost that superhuman strength for a very short period of time. It also slows down our digestive system, and that's to conserve resources. Because if you're in a fight or flight situation and your body thinks, you know, there's a threat to your life, digesting food isn't a priority. So for the same reason, things like your immune system also shut down. It's just to conserve resources so you can deal with the immediate danger. And this is why when people are stressed over a long period of time, they become unwell. That's why we catch coughs and colds and viruses more easily when we're under stress, because our stress response has dampened our immune system down so that it can focus on other things. It's also why we often feel stress in our stomach. So children might say that they've got a tummy ache when they feel stressed, and that's because the digestive system is affected by the stress response. And then finally, it even affects our vision. So to help us with better threat detection, the stress response gives us almost tunnel vision, where we have improved vision for things that are in our immediate line of sight, and we might become less aware of things on the periphery. So as I said, human survival depended on this stress response. It was essential for us to be able to carry on as a species. But these days, it doesn't feel so relevant. We're very rarely faced with threats to our survival. So what about if the threat detected by our system isn't a predator, but it's something like a playground argument for a child? Or if we feel judged by another parent, or a child kicks us, or if a child's got a homework deadline, or they're upset because of the wrong coloured cup? What about if it's these kinds of things that are stressing them out rather than a predator who's going to eat them? Well, our autonomic nervous system doesn't know the difference. So the stress response remains exactly the same. All of those things I just described, that whole impact on the brain and the body is exactly the same, even if it's over something like the wrong coloured cup. So this is a quote from a book by someone called Stephen Porges, who came up with the polyvagal theory, which is a theory about self-regulation. And he says a child's or an adult's nervous system might detect danger or a threat to life when the child enters a new environment or meets a strange person. Cognitively, there is no reason for them to be frightened, but often, even if they understand this, their bodies betray them. Okay, so this is really important to remember, because often with ourselves and even with children, we try to rationalize emotions. We say, oh, you don't need to be sad, or you don't need to worry, or it's okay. Or we might even say to ourselves, why am I getting so stressed about this? This is silly. But our bodies and our minds don't always connect straight away in that way. So even if our brains are telling us it's fine, there's no need to panic, our body doesn't always get that message in time. So that adrenaline, that cortisol, that heart rate, all of those things are still going to be triggered.